selection, which is cadangan menaik taraf kemudahan fasiliti sukan dan padang bola near at KOLEJ KEDIAMAN Tun Fatimah at UTHM. This is the project description. Our location site at Parit Raja Johor, which is developed area. The site is building a sports project, and the challenges are environment factors, weather conditions, and drainage effectiveness. Alright, as we know, our site have 2 hectare, approximately 2 hectare, and it's such a big to build a field. And then here is our project drawing specification. We have a parking lot, 48.25 by 48 meters, and then we have a small building including the toilet and so on, which is 30 by 15 meter. And then our field is like the original size, which is 105 meter by 70 meter. Alright, this is our proposed drainage design. Consists of open U-drain, swale, and perforated HDPE. Perforated HDPE has a hole in the pipe, so that we will use this kind of pipe as a substructure. We will put it under the field, so that we will line it as a herringbone system, so that when even we get a heavy rain, there is no flash flood because this kind of pipe will catch the water easily, and then if we play football there, the water can be absorbed immediately. And then from the perforated HDPE pipe, it will goes to our manhole, which is, as you can see there, between the building and the parking lot. We have a main drainage there, and then we have a existing swale along all the area. And then lastly, we have the open U-drain, which will catch the area from the parking lot. That's all.
The Malaysian Standard for Urban Stormwater Management (MASMA) Second Edition Profile Guideline for Design Pipe Drainage System to manage stormwater in urban areas effective. From the table 1, above we had chosen stored GPS Batu Pahat as our station because the site selection is Parit Raja Batu Pahat, which is in University Tun Hussein on Malaysia, Batu Pahat. The constant values for this station is 64.099. The value constant K is 0.174, is 0.201, and value is 0.826. From table 2, we had choose a pipe material, which is a concrete smooth finish as our material for purpose drainage design and running roughness, and value is 0.015. The reason we choose concrete smooth finish as our material drainage is because concrete with a smooth finish is an ideal material for drainage system due to its durability, efficiency, and low maintenance. Then from table 3, the value of runoff coefficient C is 0.40 for major system 10-year RRI, and above for sport fields, park and agriculture, while the sites that we had select the support field near Tun Fatimah College in UTHM, it meets the requirement that had been provided from MASMA Second Edition for design drainage stormwater. For sport field, a higher runoff coefficient and 10-year ARI or above are chosen to ensure the drainage system can handle large amount of stormwater.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad ZULHAKIMI ZAINI, and today I will present about calculation for line drainage. Okay, firstly we got the data from Public Info Banjir, which is rainfall intensity, and the value is 66 mm in district of Batu Pahat. And from MASMA we got 10 years RE and 9.6 minutes. Okay, to determine the design flows for the drain, we use the equation 2.2, which is I equal to delta T power of K divided by D plus delta power of N. And appendix 2B from table 2B2 from MASMA, we got location and station ID that we choose at Batu Pahat. Next is RE, storm duration, delta, K, delta, and the value of N. Okay, next we put the value from the table into the equation 2.2 to get the value of rainfall intensity, and we got the rainfall intensity, which is 222 mm per hour. And next equation 2.3, which is Q equal to CIA over 316, and we got the value of Q, which is 0.372 meter cube per second. Okay, the mannings and for concrete lining we got from the table from MASMA, which is we choose for the surface smooth concrete and 0.015. So we assume the slope which is 0.0061, width 0.90 meter, and side slope Z equal to 0. Okay, so as you can see from the table, we got the value of depth, area, wetted perimeter, hydraulic radius, velocity, and Q. So we got the depth of 0.16 meter as it meet the requirement. Okay, from the table we provide dimension of line drain, which is for width 0.9 meter, depth 0.6 meter, velocity 2.10 meter per second, discharge Q 1.13 meter cube per second. Okay, since the velocity is 2.10 meter per second, it meet the requirement for the velocity, which is 2 until 4 meter per second. And the picture below show that the proposed line drain drainage design dimension that we had provided. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FAIZ FIRDAUS bin ZAHARI. My matrix number is CF220016. Today I want to represent about the calculation of sediment basin design. So for our project location, the soil is sandy loam. So the sediment basin that we must do is in a dry sediment basin. So for the determination of basin design, so for the surface area is 290 multiply 2.02 and we got 585.8 meter square. And for the total basin volume required, 435 multiplied by 2.02 equal to 878.7 meter cube. So for the settling zone, the required settling zone average length, we got 49 meter. So it is okay. And for the average surface area, 49 multiplied by 15 and we got 735 meter square, and it is much bigger than 585.8 meter square, which is the requirement surface area, so it is okay. So for the sediment storage zone, the volume is 439.24 meter cube, and we use try and error to find the Y2, and lastly we got Y2 is 0.3 and V2 is 439.24 meters cube, and it is okay. Because the V2 that we got is 556 meter cube, and it is much bigger than the requirement sediment drainage zone volume. So for the determination of Q10, we use a sector GPS Batu Pahat, and the value that we got is 141.83 mm per hour. And then with using the method of rational method, we got the Q10 is 0.40 m cube per second. And for the determination of Q riser, after we using the formula for the Q riser, we got the Q riser is 0.23 meter cube per second. So for the Q required, we got the 0.17 meter cube per second, and for the Q spillway, we got the 0.22 meter cube per second. So the Q spillway is much bigger than the Q required, so it is okay. And then the total basin depth, including the spillway, after we calculate, we got 2.25 meter. So for the Q, we have two, which is Q pre-development and Q post-development. So for the Q pre-development, we got the Q is 0.5. So for the Q post-development, we got the Q is 0.37 meter cube per second. So this is the hydrograph sketch between the pre-development and post-development for the sediment basin design. As you can see, if the time increase, the pre-development and the post-development for Q is also increased. So as we can see, the post-development is lower than pre-development. This is because before the development, the flow may be polluted by the rubbish, so that the water cannot discharge fluently.